Hello, everybody. My name is Oguz Sunay. I'm the VP of R&D for Mobility at ONF, where I oversee all mobile-related projects. Welcome to another exciting talk at ONF Spotlight on 5G transformation with open source. Today, we have Steve Papa with us. Steve really needs no introduction, but let me do it anyway. He is the co-founder, chairman, and CEO of Parallel Wireless, one of the key companies leading the disaggregated Open RAN movement. Steve is a super successful entrepreneur. In addition to his success with Parallel Wireless, he also founded and sold Endeca, was part of the initial Akamai team, and was also a key member of the Inktomi team. He holds a BS from Princeton and an MBA from Harvard. I am super stoked to listen to Steve talk about Open RAN. Steve, the floor is all yours.
Thank you, Oguz. I will be happy to give our perspective on Open RAN. We've been working hard on it for 8 years. But in order to talk about where we are today with Open RAN, I like to start with looking back 20 years, actually 30 years, to the beginnings of the disaggregation of the data center. I started my career in the early 90s at a company called AT&T NCR Teradata. Believe it or not, that was all one company. And we were building the first Intel-based data center computer. It was a several $100 million R&D program, thousands of people working on it. And we had our own OS. I remember releasing NCR, SVR, Unix 2.1, where we'd add some features and whatnot. I remember launching a gig of RAM was $1 million. We had the world's largest data warehouse on these Intel chips. It was 1,000 chips. It was an $80 million computer. At the time, I had about 20 competitors. And I remember many of them had their own silicon. Others would say use Motorola chips, et cetera. And by the end of the decade, end of the 90s, they were all gone except for 3. It was HP, Sun, and IBM were left, and then another 5 years, they threw in the towel. People forget the most successful data center computer company in the world in 1997 was Digital Equipment Corporation. $17 billion in revenue in 1997 dollars. So call that 30 billion today. Merged into HP, disappeared. Their crown jewels was the Alpha chip. And that's what allowed them to just own the data center in the 90s. And by 2001, though, HP handed the IP for the Alpha chip over to Intel, saying, we're not going to use this anymore. We're using Intel. That's how fast the world changed. But the lesson isn't just about the fact that you could have COTS hardware. What that was about was really setting up the next 2 decades of innovation. If you think about what people thought of for a data center computer in the late 90s was a big refrigerator, actually throughout the 90s. I remember we'd worry about redundant power supplies, redundant fan trays, hot plug this and that. And if you recall, in 99, 2000, Google, was the insurgent with their cafeteria tray computers. They made the observation that if we just make each node so cheap, I'd rather have twice the nodes and let them fail and sit there than to build in all that redundancy, that doesn't add value to the compute. And that set up 2 decades of innovation. It wasn't the open hardware that changed the economics. It was the innovation cycle that went much faster, because no longer were you captive to a big vertically integrated hardware company that could only move as fast as its weakest link. Now, anyone could fulfill the role of the weakest link. Okay, so that's the movie that took place in the data center, and that's the movie we're in the early bits of in the RAN. So if you look at mobile network operators, they have a couple of big challenges. I mean, there are many others, but they kind of boil down into these 3 categories. When 4G came about, the cellular network went from a coverage technology to a capacity technology. It also went from a coverage business model to a capacity business model. the all-you-can-eat 4G data plan, okay? Prior to this, anytime you consume more, they would bill more billable minutes, more billable data. Each incremental cell site created new opportunities for more billable data. Once you go to all you can eat, though, that's no longer the case. When you add capacity, they're not necessarily getting paid more. So this has been a huge burden for operators. And I'd say that the legacy equipment vendors have had very different levels of success embracing this need of the operators to drive out cost of ownership. The second, which is this bucket of vendor diversity and innovation. Innovation I've already covered, it's too slow. And vendor diversity, it's become so consolidated. If you look at what's happened to operators, one, obviously the Chinese vendors, there's been challenges with ZTE and now Huawei. But even if you look at Ericsson and Nokia, right, it's so concentrated that they go through a few years where they're lagging far behind. And if an operator bets on a single vendor, they're going to hurt along with their vendor. So what became, if you go back to the data center analogy of the 90s, they used to be the same. No one gets fired for buying IBM, okay? Well, that became a liability at some point. And we're going through that same part of the movie here in the RAN. Then lastly, end user expectations, right? Users, want to keep consuming more and more data. We see all the projections for the amount of data consumption per user, and they don't want to wait. They want a good experience. You don't need to go seek out absurd 5G expectations. If you just use Wi-Fi in an airport lounge, you're getting 10 milliseconds. It's a great experience. And users just want that consistently. So now we'll talk a little bit about some of the technologies that go into Open RAN. There's a lot of terms thrown around. Virtualized RAN, Open RAN. Before we try to define those two, let's remind ourselves what the number one motivation for O-RAN was originally. It's the proprietary interface between the baseband, the bottom of the tower, and the radio at the top. What that does is if someone, I'll give you a real example of an operator that has a very successful 2G, 3G, 4G network, and they wanted to turn on VoLTE at some point. There are very little phones in this country that support VoLTE. Their provider of equipment, I think, wanted a $25 million license just to turn on VoLTE, day one, anywhere. There was no in between. There was no, perhaps, maybe if it's just 5% of our calls on our network, we can negotiate. There's none of that. It's just a flat, that's the cost. When this is a minor software upgrade. Now that operator, in a world where there was interoperability between the radios and baseband, could have just decided to go to 100 sites, put in someone else's baseband that supported VoLTE, and they'd be in business. But they didn't have that option because of that proprietary interface, okay? The way this directly translates into increased costs is the incumbent has the advantage of the cost of the truck roll to go to the site and climb the tower relative to an alternative. And operators wanted to fix that. So that core idea of Open RAN has also encompassed this idea that if you pick the right place for the interface between the radio and the baseband unit, you can use COTS equipment for the baseband equipment. You don't have to. And in some ways, some people have decided that's the more important piece and that you can keep proprietary links. So vRAN is the idea that you can have a proprietary link, but use COTS hardware for the baseband unit, okay? True Open RAN is that it's an open interface and you have interoperability, which is, adheres to the original spirit of O-RAN. Our approach is to be wide open, okay? Instead of vertical stacks, and in fact, this picture doesn't quite capture it because on a typical cell site, it's the same vendor across those Gs. In our world, we not only do we deaggregate the hardware, software, and services, we deaggregate the Gs. You'll see us provide, in the future, some of the Gs, someone else might provide other Gs. There's all different ways this is going to work. Okay. Giving operators maximum flexibility. When you look, at the technology, it's one thing, but as I emphasized at the beginning of this, the technology, while it's interesting, it's really about how we set up the innovation process. Today, in order for someone to participate in innovating in the RAN, you have to build the entire set of RAN equipment or convince one of the few big RAN vendors to let you in, okay? And to let you in on terms that you'll be able to survive. So it's hard enough to even get them to consider something other than their own ideas. And then number two, when they do like something, they destroy the vendor in the process. Okay, that's why there's so little innovation. There's so little investment. Investors have seen this happen, and venture capitalists stopped investing in this sector. With the interoperable interfaces and use of COTS hardware where you can, all of a sudden, for someone to innovate, you have to do less and less of the total solution. You can just do your part really well. Right? It's been a long journey for us at Parallel Wireless because we're trying to fill in all those gaps. But what's exciting now is people can approach us with a piece, even if it's a piece we've already built, and they're doing it better, and we want to work with them. Right? That's the promise of Open RAN. This here exemplifies, just let's look at the different colors, just mean a diversity of providers, okay? Now, it doesn't start on day one with maximum diversity, right? It's something that as you start out, you get your first interoperability between a vendor and another vendor of hardware. Then you get interoperability with a second vendor of hardware. And then you start, another software vendor that works with both those hardwares. You're each able to provide pieces, right? And you get this geometric expansion. It does not happen on day one, but it's a process, right? If you remember back in the early aughts, VMware used to certify hardware, and they would be the one that would spec out your data center and build it. As VMware had success, though, Intel decided to bring the hypervisor right into the silicon, and then VMware no longer had to worry about certifying hardware. And systems integrators were able to take the lead in speccing and building these systems. So what do the people actually deploying Open RAN have to say? Well, we're proud that one of our customers is it's an operator here in the United States. Not many people know there's 100 operators in the United States. Inland Cellular is one of the small regional ones. And in fact, they're going to be able to grow their coverage significantly because we drove down the cost per site. Hundreds of new sites will be put up because their cost per site has gone down. When you hear about many of these programs that governments have to drive rural coverage, if they just put a portion of that investment into the R&D to drive out cost, they grow coverage far faster, right? And this exemplifies that possibility. Okay. With Vodafone, we're very thrilled to be working with them. Obviously, they're amongst the world's leading experts. We're thrilled to have them, really driving our roadmap as to what's most important to be able to provide a comparable experience for existing sites. One of the cardinal rules of the cell network is thou shalt not regress capability. And that makes it very challenging, right? We have a lot to do. And Vodafone's worked with us very closely to say, look, this is what's important. Don't worry about this other stuff. And we're aiming for very ambitious things to give Vodafone much more supply chain flexibility over the coming years. So to summarize, because this is a short presentation, Open RAN, has enormous potential. It's a movie, though. It's not a short movie, right? Just like the data center, it extended decades. We're at the beginning of this, or you could argue the virtualization of the of the core was the start. And this is the next piece, which is the much bigger piece. Ultimately, Open RAN will be the dominant, I mean, almost, it might even be the exclusive way RAN networks are built 5 years from now. I like to make the case that, you know, the radios, once Open RAN radios, because you have more innovators working on them, are superior to what comes from proprietary legacy vendors. Overnight, every vendor has to support Open RAN. And I'm going to bet on the innovators that we're going to get better radios from the people pushing the boundaries than from incumbents within 2 years. So we have a lot to look forward to, and I appreciate everyone taking the time to hear the story.
Thank you, Steve, for the great presentation. As you rightfully said, you know, the Open RAN story is just starting, and it is not a quick one. It is going to be a marathon. The initial focus in the RAN disaggregation is the disaggregation of the stack into multiple components, RU, DU, CU, that we have in the ORAN architecture. And that's where the majority of the work is happening, creating the interfaces for openness, allowing multi-vendor, and that's where Parallel Wireless is doing a great job. The next phase is undoubtedly the SDN-based disaggregation that brings in the near real-time RAN intelligent controller into the picture. So what are the efforts within Parallel Wireless, if any, in this dimension of disaggregation? And do you plan to move in this dimension with in-house development, or participate in open source developments, or partner with other companies? What are your thoughts?
Sure. So let's first start, you know, I agree those are big parts, but if you were to ask me where my time goes, it's actually on the radio. All of my time is, not all of it, but the vast majority is working with those innovators to crack that nut. Because at the end of the day, it is a wireless network. That's the tail that wags the dog. If you look at where the spend is, right, the electric bill, you know, the real estate on towers, et cetera. That said, when I look at things like the RIC, right, the answer, you asked, are we going to work with some existing ones, in-house development? The answer is both. Right? The entire point is to embrace open interfaces and best of breed approaches, right? The one of the nice things about, you know, continuous integration and cloud computing, the burden to keep best of breed components working together well is very different than it was in earlier eras, right? We're all designing these things with deaggregated services. They're expected to function across boundaries versus monolithic, you know, style.
All right, thank you. When you actually gave us sort of a historical synopsis, we heard you talk a lot about data centers. So that effectively brings to my mind enterprises. So with CBRS and CBRS like Spectra around the world, what are your thoughts on private networks? Do you think that they could or they would play a role in advancing the Open RAN?
I think private networks absolutely will advance Open RAN, but I think it's through the lenses of something that it spans both Wi-Fi 6 and Open RAN. Okay, when you look at the amount of spectrum that's being made available for Wi-Fi 6, I mean, you're talking over a gigahertz of spectrum. You can't ignore that. You just can't. The good news is, at a technical level, Wi-Fi 6 and 5G are very, very close cousins, right? They're both OFDMA.
Yeah.
Right? And in a situation of a lightly loaded cell, the compute requirements between the two are very, very similar. So we're going to see innovation there that brings those two worlds together. And if there's one thing that Wi-Fi taught us, if the cost is low enough, it's going to be pervasive, right? I think back just 4 or 5 years ago, I won't name the vendor, but there was someone pushing femtocells thinking dual mode femtocells for $5,000 a piece was a market. There are operators spending that much for their three sector macro cells.
Yeah.
Right. And providing just a little bit more coverage than that cell was going to cover. So
yeah. Excellent. In general, we're talking about Open RAN. What do you see as the biggest risk as the Open RAN community we need to sort of be cognizant of and overcome to enable and hopefully expedite this transformation?
I think the biggest risk is that the Open RAN vendors see themselves as competitors versus their number one mission is to look across their assets on how do we get to total solutions that get this ball rolling. Okay. And if people close up and they just see themselves as, enemies versus no, our enemy is vertical integration.
Yeah.
Right. That's going to delay it a lot longer.
All right. Then maybe one last question is, how do you see the market evolve if disaggregation and multi-vendor solutions like you were talking about is the desired outcome? Do you think the operators and the industry is prepared for this? By that, I mean, are there really systems integrators who would already enable this for the operators because they don't necessarily have the in-house DevOps teams?
Yep.
We have seen this with Rakuten and now maybe with Dish, but for this to become the norm, what are the missing pieces?
So that's a very good question. There are two parts to it that I'd like to address. One is just the capability to operate and deploy these things. Okay, we did see the adoption of things like the virtualized core were certainly hampered by operators' abilities to run a data center, right? And it's more because the operators had outsourced everything, right? The prior decade, okay, and they outsourced it to people that had no interest in seeing a virtualized core, okay. Now, that opens the door to a lot of SIs to come in, just as they did in the virtualized data center. So, as well as cloud providers, Microsoft's notable acquisition is a great example of it. In many ways, Microsoft is going to make it a core service like AWS's Redshift. And that's it. Core's done. Nothing more to do, right? But there's one thing that could get in the way here, and this goes back to your risk point. The operators could destroy this. Okay, the operators have built up their procurement practices to an art form to where they could create a self-fulfilling prophecy, right? If they look at Open RAN as a way to squeeze out cost in the immediate term, they will also squeeze out this future innovation. It won't happen. It won't get going. They have to think about how do they have to invest along with everyone else in getting that innovation cycle going.
All right. Thanks, Steve. That's it from, I guess, my end.
All right, great.